Okay, here's our first word problem fun practice. The temperature of a liquid is increasing at the rate of 3 degrees Celsius per hour. When Julian begins measuring the temperature, it's 20 degrees Celsius. Write a linear function that describes the temperature of the liquid over time. Then make a graph to show the temperature during the first 10 hours. So what I've done on the paper here, not so neatly because my iPad is scratched, I have gone ahead and labeled the axes. If you notice, the x-axis, which is right down here, is labeled as time in hours, and the y up here is in temperature, which is in Celsius. And what I did is I tried to space out just a little bit the hours. I did 2, 4, 6, 8, and 10 down there in a scribbly orangey color. And then up the side, I started at 5. And I did 5, 10, 15, 20, and 40 are written in blue, if you can decipher those. Just, you can space some of them out. You can write all the numbers in. You can write every few if you want. So let h equal hours. We need to write a linear function that describes the temperature of the liquid over time. So we have y equals, and now I need to come up with the function. Let's see. It's going to be increasing at a rate of 3 degrees per hour, but it starts at 20 degrees Celsius. So that's your starting point. You've got 20 degrees, and it's increasing, which means plus, at a rate of 3 degrees per hour. There's your 3, and there's your times h. So y equals 20 plus 3h. When you start to graph it, your first point that you're going to start at will be 20. And that's your dot right here. And then it's going to be increasing 3 degrees every hour. So this is, in a sense, right here. That's your 0 hours. That's where you started. Then the line that's not labeled that 1, that's the first hour. So after the first hour, it's going to go up 20 to 23 degrees. So your dots are not going to be exactly in those crosshairs. They're going to be a little bit above. And so you're just going to slowly go up and try to estimate in between those crosshairs where it's going to be until you hit the 10-hour mark, which should be somewhere around here. You can go ahead and fill that in. And thinking about whether we're going to connect the dots or not. Can you connect the dots when you're talking about temperature over time? Yes, you would, because you could look at it at 2.5 hours. You could look at it at 4.5 hours. The temperature would be in between all these, so make sure you connect the line on this one. Now this problem talks about the water level on a well. So you have a well, and the water level is at 30 meters. So here's our well, there's our water, and it's at 30 meters. There's your well. Water seeping out of the well and into the ground at a rate of 5 meters per year. So it's seeping out. Write a function that describes the water level after X years. Then make a graph that shows the water level after each year. At what year will the well be empty? So they've told you they want X to be years. So you've got y equals, it's starting at 30, but water is seeping out. So is seeping out going to be an addition problem or a subtraction problem? It'll be a subtraction. And what is the rate at which it is seeping out? 5 meters per year. You can see that I've already done my labels for my axes, time in years and water level height in meters. I've done the height going up, 5, 10, 15, 20, 25, 30, 35, 40. Down at the bottom, you can fill in the years. If you want, you can go ahead and skip again every few spaces so you can kind of space it out. So you can take this all the way out. And where are we starting? Water level starting at 0. 30, 0 time, 30 meters. And then you're going to figure out what happens after the first year and go ahead and plot those points. And then determine what year will the well be empty. And don't forget your context sentence, capitalization, and punctuation. This is on the left-hand side. Max used the equation 1 equals 100 plus 25x to track his savings after X months. If the answer is 250, what could be the question? So I want you to think about this in context of a real-life situation and figure out what a question could be, maybe figure out what X could be, and I'm going to let you work on that one by yourself. Next one is graphing the function negative 2x plus 1. I want you to think of the ordered pair x negative 5. It's going to be on that graph, and what would the value of x be? So you could do some guess and check. You could fill in some ordered pairs as I've done down here and go ahead and plot those points. When you're drawing your line, make sure you extend your line all the way from one side of the graph to the other. So, for example, I want you to extend it all the way through, something like this, if the graph happens to be in that area. Or you can even extend it, all the way. Just make sure you draw it all the way out. Don't just do a little graph like this, because it's not giving me enough information. Down below I gave you negative 2, negative 1, 0, 1, 2. You can use those or you don't have to. Regardless, you are going to have to connect the lines, to connect the dots to create a line. Just be careful. Make sure you put in at least one negative. When you have a negative times a negative, you see negative 2 times negative 2 gives you positive 4, plus 1 is 5. Just be careful with your integer rules. Now we're on to the last page. This one's about bacteria, and this bacteria divides every 30 minutes. The function that we're using here is y equals 2 to the x power to determine the number of bacteria after each half-hour period, where x is the number of half-hour periods. So you can see down on this x-axis here, I have labeled the number of half-hour periods, 1, 2, 3, and 4, which you'll see in the box. You need to recall your exponent rules. 3 to the second power is 3 times 3, which gives you 9. 3 to the third power is 3 times 3 times 3, which gives you 27. So fill in this center part here and go ahead and expand it out. Don't forget your labels for the x and y axes. And I didn't do any labeling here on the side for you. I want you to be able to figure it out for yourself. Good luck with this, and I hope you enjoyed your day off.